Hello students, welcome back. I have included this question as homework in one of my previous videos. Many of you have doubts with respect to this and you don't know how to solve this question. That's why I'm going to quickly solve this. See, what should be the approach? Identify the functional groups. There is an alcohol, there is ether, and then there is a double bond, and it is treated with concentrated H2SO4. When do we use concentrated H2SO4? Either acting as a catalyst or dehydration, condensation, etc. But what it is doing here, we don't know. So just quickly go through the options. See, there is a ring expansion. So most probably this could be the product. And here dehydration. And what about here? Again, elimination reaction. So let's see what might be happening. Whenever there is an alcohol and a double bond, where the electrophile should attack. Generally, it attacks the alcohol, but here this is a special case. Why is it a special case? Because there is a double bond which is attached to the oxygen of the ether functional group. So there is some neighbor group participation over here because of the lone pair present on the ether. So in that case, this double bond is electron rich as compared to the alcohol. Why so? Look at this. It is undergoing resonance like this, right? So because of this, what happens? So you see this alcohol will remain as it is. You keep this as it is. What about here? You have to form double bond over here. The electrons are here. So assuming these electrons are given to the proton, right? So when the electrons are given to the proton, what happens? See, usually all these things happen simultaneously, but for your understanding, I'm writing like this, all right? So oxygen cannot have positive charge for longer time because it is a electronegative element. So what happens? It will take the bonding electrons, the whatever pi electrons are there here, it will take those electrons. And now what happens? There should be a lone pair, two lone pairs on oxygen, and the positive charge should be over here. And there is a possibility of ring expansion as I told you earlier. How do you show that? Look at this. These electrons will come here. This carbon becomes pentavalent, which is very difficult. So the ring expansion will take place here. If you don't know how to write this, just follow my lead. You write down this tetrahydrofuran molecule as it is, and then look at this bond remains as it is, write that, right? So then to the same carbon there is a ketone formation like this. Why are we removing this proton here? Because we are regenerating the catalyst H plus. That is the reason. So when the electron moves here, the double bond is formed here. So 1 2 3, you write 3 CH2, 1 2 3. And where is this bond is moving to? Here, like this. So you got a cyclopentanone molecule. And what is this compound? This is a spiro compound, bicyclic compound, but one is ether, the other one is ketone. And where do we have it? Option A. Hence the correct answer is option A. And if you still have questions on this, please don't hesitate to comment. And all the best for your upcoming exam, and please let me know how you did in your exam. Good luck.